Hello scientists, and welcome to this video on series and parallel circuits. Before you watch the rest of this video, please make sure you have a copy of the notes from class and something to write with. All right, let's get started. So there are two main types of circuits. The first one is called a series circuit, and it's a circuit in which current can only follow one path. So these are the basic circuits that we've been looking at so far. A parallel circuit is a circuit that has at least one branch point where the current splits into two or more pathways. So there's more than one path for the current to take. I'm going to show you some examples. So here is a series circuit. There's only one path for the current to follow. So here you can see that all of the circuit components are connected, and the loads, the light bulbs, are connected in series. There's only one path the current can flow through: the battery, switch, and loads. So the electrons are going to come along here, go through the switch, and then when the switch is closed, it will light up these three light bulbs and come back. If for some reason the circuit is broken, like one of the light bulbs is burnt out, the light bulbs that come after it won't work anymore. So that's the downside to a series circuit, is that the loads farther along the circuit are dependent on the ones earlier in the circuit working. Over here is a circuit diagram using the symbols of what this looks like, although I realize now that the switch is on the wrong side, I believe. Yes, so remember that our battery diagram, the short side is the negative terminal or connected to the anode. So this switch should actually be down here. But other than that, it is the same as this one right here. This is an example of a parallel circuit. It's a circuit that has at least one branch point, or one place where it splits into different pathways. So here, the light bulbs, the loads, are connected in parallel, although the battery and the switch are connected in series. And at the branch point, the current here will split into two pathways, and the sum of the currents in these three pathways is the same as the current over here before the branch point. So we're going to get into doing calculations with current next lesson, but as the current comes here, 1/3 of the electrons goes to this path, 1/3 of the electrons goes to the second path, to the second light bulb, and 1/3 of the electrons comes to the third one. So if you added up the current in these three light bulbs, it would be equal to the current over here in the wire connected to the battery, or right here, or right here. Here's the circuit diagram of the circuit you just saw on the previous slide. So again, here's our negative terminal. Electrons will come here. If the switch is closed, they'll come down and then go into one of the three pathways. Now in this diagram, if the middle light burnt out, the other two would just work just fine. Or if the first light burnt out, these bottom two would work just fine. In a parallel circuit, each branch is independent of the others. So here we have a comparison of a series circuit and a parallel circuit. So over here, letter A, the series circuit only has one pathway for the current, and the current is equal in all parts of the circuit. There's the same number of electrons traveling through anywhere along the circuit. If you hooked up an ammeter, which measures currents, it would read the same thing no matter where you were in the circuit. Over here we have a parallel circuit where the current splits into three paths, so the current is reduced in each pathway. So if you see here, there's fewer electrons in the path with the load than there is in the conductor between the source and where it splits off. So if you put an ammeter here, it would be higher than if you put an ammeter here to measure the current. So let's talk about circuits in a home. What do you think is more practical for the circuits in a house? A series circuit or a parallel circuit? Take a second to jot down which one you think and why. Okay, so parallel circuits are more practical for homes, and I'm going to show you why. So let's start with why series circuits are not practical for homes. So think about what you have in your kitchen. all of the different loads you have, like a ceiling light, a fridge, a microwave, your toaster, your kettle. If one load, say the light in your kitchen ceiling, burns out, the circuit is going to be open, like an open switch, and the charges will stop moving. So no other loads, like your microwave or your toaster, would work. Nothing in your kitchen would work if one thing burnt out or broke. Parallel circuits, on the other hand, are practical because each appliance is controlled by its own switch, so it won't be shut off by the others. So for example, in this diagram, in letter A, all of the appliances are running. A large amount of current is passing through the conductor wire. So where this blue arrow is, there's a lot of current here. It's worth noting that if you have too much current going through a conductor, like a wire, it can get really, really hot and even set on fire. So we have some safety things in our homes that I'm going to talk to you about later or in class. So in B, if you turned off your ceiling lamp and you turned off your microwave, maybe it broke or you just turned off the main power, the toaster and radio can still run. Whereas in a series circuit, if one thing was turned off, everything would get turned off. So that's why we use parallel circuits in our homes. And we have multiple circuits in our homes. So many separate parallel circuits are installed in buildings, and a large electrical cable carrying electrical energy comes to the building and then branches out and is connected to each parallel circuit in a circuit panel, or sometimes you might hear this called like a breaker panel or just an electrical panel. So we've got a large cable coming in from the power company, and then if you opened this up, you would see fuses, which I will explain in a different video, but basically you've got all these little parallel circuits coming out from one main spot. I hope that helped explain what series and parallel circuits are. If you have any questions, you can ask me in class, and you can move on to the next item on your playlist. Have a great day.